Good day, students. Myself, Dr. Monica Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. In my lecture series of MSc Final Physics, we are dealing with the paper 5th. We were discussing superconductivity. In my previous lectures, we have described what are superconductors and its important phenomena. We have also discussed critical magnetic field. Critical magnetic field is the value of magnetic field that is needed to destroy superconductivity. It is denoted by Hc. When we place a superconductor in a magnetic field and we increase the magnetic field, then at a particular value, which is termed as critical magnetic field, the superconductivity of the material destroys and the material changes from superconductor to normal material. Now, in my today's lecture, we will discuss Silsby rule. What does this rule states? What are we doing? We are taking a superconductor. Now, we are changing the value of current. When the value of current exceeds a certain value of current, this certain value of current is known as critical current. Above this current, material will change into a normal material. Similar as was in the case of critical magnetic field. Above critical magnetic field, material is normal, and above the critical current, the material is normal. This current is denoted by Ic and it is termed as critical current. Now, in order to determine the formula of critical current, I am taking a superconducting long circular wire. Let the radius of this circular wire be R. We are going to pass the current through this wire. Let the current passing through the wire be I. Now I am increasing the value of this current. It is found that at a value I equal to Ic, the current becomes critical current. Above this current, the material will become normal. That means this is the minimum value of current that is needed to destroy superconductivity. Now, I am using the Ampere's circuital law. What is that law? Line integral of H dl equal to I. Therefore, from here, H will be equal to I upon 2 pi r. As we have taken a wire in the circular shape, its length will be equal to the circumference, and the circumference of the circle is 2 pi r. Now I am taking the condition at which I equal to Ic. Now since at I equal to Ic, superconductivity is destroyed. So the value of H will be equal to the critical magnetic field. Since this also denotes the value at which superconductivity is destroyed. So instead of H and I am taking Hc and Ic. So my expression becomes this. So from here we can easily determine the value of critical current. Critical current Ic will be 2 pi r Hc. Now, since I know the value of critical current Ic, I can find the value of critical current density. Critical current density Jc will be current per unit area. Current is Ic and area, since the wire is circular in nature, the area will be equal to pi r square. Substituting the value of IC and solving, I will get Jc to be equal to 2Hc upon R. So, I have obtained my formulas of critical current and critical current density. Now, this phenomena of critical current, that there is a disappearance of superconductivity above critical current, or we can say that there is a disappearance of superconductivity above critical field. This is the principle on which cryotron operates. Now, since according to the Misner effect, we have magnetic field inside the superconductor to be 0. What is Misner effect? Misner effect states that when a superconductor is placed inside a magnetic field, then magnetic field lines will be outside the superconductor. In the interior of superconductor, B will be 0. Now, using the relation between B, H and M, since B equal to mu 0 H plus M, here mu 0 is permeability in vacuum, we will have, by putting B to be 0, I will get M to be equal to minus H. Now, using the relation between M and H and relative permeability, the relation is M equal to mu R minus 1 H. Putting M to be equal to minus H, I will get mu R to be equal to 0. So, relative permeability is 0. For a superconductor, we have obtained relative permeability mu R to be equal to 0. This is an important rule which is termed as Silsby rule. It determines the value of critical current and critical current density. IC to be equal to 2 pi RHC and critical current density being Jc equal to 2Hc upon R. Now I am going to discuss the another important properties which change in the superconducting transition. First property is dependent on magnetic field. I am taking two materials. Firstly, I am taking a pure superconductor. Now, another material is normal. And we are placing both the materials in magnetic field. Behavior of these two materials is different. In normal material, magnetic field lines will penetrate inside as well as outside the region. Whereas in superconductor, magnetic field lines will be only outside the superconductor. Inside the superconductor, B will be 0. Thus, if we have a temperature above Tc, the material will be normal and field lines will be everywhere inside as well as outside. But when a superconducting transition takes place at Tc, then inside the material B will be 0 and outside there will be magnetic field lines. So we have that in a pure superconducting state, no magnetic flux is able to enter the metal. And we have proved that it will have zero permeability, or we can say that it will be strongly diamagnetic in nature. This effect is termed as Misner effect. Another property which changes at Tc is the specific heat. We have already discussed the variation of specific heat with temperature. And we have shown that at T equal to Tc, the specific heat changes discontinuously. there is an abrupt jump at T equal to Tc, which shows that this transition is second order transition. And there is also a small change of volume at transition in the presence of magnetic field. Now we are going to discuss the third property. Thermoelectric effects. They disappear in the thermoelectric effects. They disappear in the superconducting state. These effects are present in the normal state. When we have a material and we are going to determine its thermal conductivity, it is found that the thermal conductivity also changes discontinuously when the superconductivity is destroyed in the magnetic field. By comparing a pure metal superconductor and pure metal in a normal state, it has been observed that in the superconducting state, thermal conductivity is lower for pure metal, but for certain alloys, it is higher. These alloys are exceptions. The fifth property is entropy. If we measure the entropy in both states by the variation of temperature, then it has been found that entropy in the superconducting state is less as compared to normal state. This shows that superconducting state is more ordered state. Less entropy, more order. That means as compared to the normal state, we have a superconducting state which is more ordered state. So students, these are the important properties of superconductor. Using this Silsbee rule, we can find critical current and the critical current density Jc, which is equal to 2Hc upon R. Silsbee's rule states that when the current exceeds a critical current, then material transform from normal to superconducting state. Thank you students for watching.